Hello everyone. My name is Sri Rekha. I'm from Excell Study Circle. So this will be a third session on the chapter Matter in Our Surroundings. This is the chapter from class 9 CBSE textbook. So let's have a quick recall on whatever we have learned in the previous session. So first we have learned about matter. So any substance which is having its own mass, which is having its own volume, which can be perceived by a senses can be called as a matter. And we learned about the characteristics of particles of matter. The particles of matter, they are having some space in between them. They are continuously moving and they are having a force of attraction between them. Then we learn about diffusion, which is a process in which the intermixing of two different states of matter on their own they happen. And whenever the temperature is more, diffusion is happening at a higher rate, we have learned. So temperature and diffusion, they are directly related, as when the temperature is raised, the kinetic energy of the particles is increased, and thereby diffusion can happen at a faster rate, we can say. Then we have learned about the fundamental states of matter, which is solid, liquid, and the gas. We have learned about the characteristics of all these states of matter. Now in today's session, we learn, can matter change its state? So let's start with, we all know from our observation that water can exist in three states of matter: solid as ice, liquid as familiar water, and gas as water vapor. What happens inside the matter during this change of state? What happens to the particles of matter during the change of state? How does this change of state takes place? We need an answer to these questions, isn't it? So let's check the effect of change of temperature. This is activity 1.12. I hope everyone is ready with your notebook as well as the textbook. Okay. So let's see this activity. Take about 150 gram of ice in a beaker and suspend a laboratory thermometer so that its bulb is in contact with the ice. As in figure 1.6 they have shown. Okay. This is the setup they have shown. So let's have a quick recall. Okay. They have fitted an iron stand over here. Then we are having thermometer, then glass stirrer, beaker, then we are having ice as well. Okay. And the thermometer here we have fitted in order to measure the temperature in between. Okay. So what happens is that, let's check this activity. Okay. And the second one, they have given the conversion of water into water vapor. Okay. So start heating the beaker on a low flame. Note the temperature when the ice starts melting. Note the temperature when all the ice has converted into water. Record your observation for this conversion of solid to liquid state. Now put a glass rod in the beaker and while stirring till the water starts boiling. Keep a careful eye on the thermometer reading till most of the water has vaporized. Record your observation for the conversion of water in the liquid state to the gaseous state. Okay, so let's come back to the same setup again. So what happens is that when you check this experiment, we can see the ice starts melting when the temperature is slowly given, right? And we are having a glass stirrer in order to stir it continuously so that the process can happen at a faster rate. So here what happens is that when ice starts melting, we can see the temperature value is going to be 0 degrees Celsius. It remains at 0 degrees Celsius till all the ice melts and it gets converted into water. Now, what happens in the second setup is that here, now all the ice has been converted into water. Now, when again, if you raise the temperature, what happens is that water will slowly convert into water vapor. Okay, and again we can note down the temperature as well. Okay, so on increasing the temperature of solid, the kinetic energy of the particles increases. Okay, so temperature and kinetic energy, they are directly related, we can say. Okay, directly related to uh, kinetic energy. All right, the particle starts vibrating with a greater speed. The energy supplied by the heat overcomes the force of attraction between the particles. The particles leave their fixed position and starts moving uh, randomly or freely, we can say. A stage is reached when the solid melts and it is getting converted into liquid. The minimum temperature at which a solid melts to become a liquid at the atmospheric pressure is called as melting point. And this definition is going to be like very important. Please take a note on this. Okay. So the minimum temperature which is required for a solid to get converted into vapor state is called as melting point. That particular temperature is melting point. So when you take the case of ice, it is 0 degrees Celsius. All right. The melting point of a solid is an indication of the strength or force of attraction between the particles. Okay, these 2 points are going to be important. So we can say that if the melting point of a particular substance is very high, meaning too much of energy is required to break the force of attraction, or to overcome the force of attraction between the particles, we can say. Okay, so it is an indication, as they've already suggested. The melting point of ice is 273.15 Kelvin in terms of Kelvin, another unit to calculate temperature. Otherwise, it's going to be 0 degrees Celsius. The process of melting, that is change of solid state into liquid state, is known as fusion. So we can understand that fusion is sometimes called as melting. Okay, both are the same. Another word for melting is fusion. All right. When solid melts, its temperature remains the same. So where does this heat energy go? This question is very important. We can expect this question for your examination as well. So you must have observed during the experiment of melting that the temperature of system does not change after the melting point is reached till all the ice melts. This happens even though we continue to heat the beaker, that is, we continue to supply the heat. This heat gets used up in changing the state by overcoming the force of attraction between the particles. So just one point, when the ice melts, when it is completely changed into water, till that time the temperature is going to be 0 degrees Celsius. There is no change in temperature, right? When all the ice is being converted into water, till that time we are having a 0 degree Celsius temperature. So the question here is, so still we are supplying the heat. Where does the temperature go, or where does this heat energy go? In one simple phrase we can say, or in one simple sentence we can say, all the heat energy that we are supplying is used to break the force of attraction, to change from one state into another. So this heat energy that we are supplying is in the hidden form, we can say. Okay, we call it as latent heat, and here it is used for conversion of from one state into another. Okay, as this heat energy is absorbed by ice without showing any rise in temperature, it is considered that it is hidden into the contents of the beaker, and it is known as latent heat. So sometimes we call latent heat as hidden heat. The word latent means hidden. The amount of heat energy that is required to change 1 kg of a solid into liquid at the atmospheric pressure at its melting point is known as latent heat of fusion. So you can expect two definitions over here. The first one is, what do you understand by latent heat of fusion? The second one is, what do you understand by latent heat of vaporization? The definitions are going to be like somewhat similar. You just need to like change the um, keywords or the terms here and there. Okay, so suppose you're having 1 kg of solid in you. You want to convert that solid into liquid state. So definitely you will require some heat energy for this process to happen, right? So that heat energy is called as latent heat of fusion, and this happens at its melting point, since fusion is nothing but the process of melting. So once again, by definition, if you want to define what do you understand latent heat of fusion, we can say that it's nothing but the amount of heat energy which is required to convert a unit mass, or you would say to convert 1 kg of a solid into its liquid state at the normal atmospheric pressure at its melting point, is known as a latent heat of fusion. So the particles in water at 0 degrees Celsius, which is again 273 Kelvin, have more energy as compared to the particle in ice at the same temperature. So this is again going to be very, very important. If you take ice at 0 degrees Celsius, if you take water at 0 degrees Celsius, which is going to have more like energy. Okay, so particle in water, it's having more energy. Why? Because the energy in water when compared to that of ice is more, and that is stored in the form of latent heat, we would say. Okay, now the next one, when we supply heat energy to water, particles start moving even faster. At a certain temperature, a point is reached when the particles have enough energy to break free from the force of attraction of each other. At this temperature, the liquid starts changing into gas. The temperature at which a liquid starts boiling at the atmospheric pressure is known as boiling point. So boiling is a bulk phenomenon, and the particles from the bulk of the liquid gain enough energy to change into the vapor state. Okay, so we are having one more definition over here, which is boiling. It's nothing but the process in which the liquid gets converted into its vapor state. That process is called as boiling. And what do you understand by boiling point? It is that particular temperature at which the liquids just starts boiling. Okay, and it gets converted into vapor state, we can say. So for water, this temperature is 373 Kelvin, which is nothing but 273 plus 100, which would give you 373 Kelvin, or we can say it is 100 degrees Celsius. This is a boiling point of water. Understand that different liquids are having different boiling point. All right. Can you define latent heat of vaporization now? The same definition here and there, we can have a sort of change in between, okay, regarding the keywords. So we can say that the amount of heat energy which is required to convert a unit mass of liquid or one unit mass, unit in the sense one liter of a liquid into its vapor state at its boiling point at the normal atmospheric pressure can be considered to be latent heat of vaporization. All right. So yeah, particles in steam, that is water vapor at 373 Kelvin, that is 100 degrees Celsius, have more energy than water at the same temperature. See, this question is also very important. The question can be asked like steam at 100 degrees Celsius or water at 100 degrees Celsius, which is having more energy. Definitely steam at 100 degrees Celsius is having more energy in the form of latent heat of vaporization, we can see. And the burns caused by steam is going to be very severe. All right. So you can answer this as this is because the particles in the steam have absorbed extra energy in the form of latent heat of vaporization. Now we can learn about the interconversion of states of matter. Okay, this is very important as well. So solid state, when heat is given, it gets converted to liquid state. From liquid, when heat is absorbed, it gets converted into gaseous state. When the temperature is lowered or when it's cool, the reverse happen. The gas can be converted into liquid, liquid can be converted into solid state. So we infer that the state of matter can be changed into another state by changing the temperature. By increasing the temperature, we can change from one state to another. The same way the reverse can also happen, right? We have learned the substances around us change from solid to liquid and from liquid to gas on the application of heat. But there are some changes that directly change from the solid to gaseous state and vice versa without changing into the liquid state. They've given activity 1.13. So take some camphor, crush it and put it in a china dish. Put an inverted funnel over the china dish. Put a cotton plug on the stem of the funnel as shown in the figure. The cotton plug is being fixed so that the vapors won't escape. Okay. So what happens is that when you supply heat with the help of a burner, the camphor starts vaporizing. Since at the upper part over here the temperature is less, after some time we can see the vapor solidifies, and you can see the solidified camphor, it is getting stuck on the sides of the funnel. Okay, this is experiment. So from this, we can see that a change of state directly from solid to gas without changing into liquid state is called as sublimation. And the direct change of gas to solid without changing into liquid is called as deposition. So sublimation is nothing but the conversion from solid directly into gas without that intermediate liquid state. And the reverse of sublimation can be called as deposition. Okay. So this definition also you can learn. Now, the next topic is the effect of change of pressure. We understood that by increasing the temperature or lowering the temperature, we can change the state of matter from one into another. So what if we change the pressure? Can we change the state of matter? Yes, of course. So we have already learned that the difference in the various states of matter is due to the difference in the distances between the constituent particles. What will happen when we start putting pressure and compress a gas enclosed in a cylinder? Will the particles come closer? Do you think that increasing or decreasing the pressure can change the state of matter? Yes. So they've given a simple experiment. They've taken a piston over here, a cylinder. By applying pressure, By increasing the pressure, we can see the volume is getting reduced. So pressure is increased, we can say volume decreases. So P and V, they are inversely related. Inversely related in the sense, if one quantity increases, the other decreases. Okay. So applying pressure and reducing temperature can liquefy gases. Okay. This is a very important statement. Take a note on the same. Have you heard of solid carbon dioxide? Is nothing but the dry ice. Okay, it is stored under high pressure. Solid CO2 gets converted directly into gaseous state on decreasing the pressure to 1 atmospheric pressure, okay, 1 atm, without coming into liquid state. This is the reason that solid carbon dioxide is also known as dry ice. Okay, you can see this same dry ice in the stage performances, where you can see a cloudy or a foggy kind of effect in between the stage shows. It's nothing but the dry ice. Okay, thus we can say the pressure and temperature determine the state of a substance, whether it being a solid or a liquid or a gas. And this figure is very, very, very important. Please learn the same. Like solid getting converted to liquid, it is called as fusion or melting. Liquid to solid, it is solidification. All right. Solid to gas, it is vaporization. Either it can happen with the help of boiling, or the simple evaporation can happen. Gas to liquid, it is condensation. Solid directly to gas, sublimation. Reverse of sublimation is deposition. This flowchart is, or this figure is nothing about the interconversion of states of matter. Okay. So please learn the same. Let's have the in-text questions now. Convert the flowing temperature into Celsius scale. This is 300 Kelvin. So the first question, 300 minus 273, which would give you 27 degrees Celsius, right? That's the answer. And the big question, this is for A. Take a note on the same. For B, it is 573 minus 273, which would give you 300, right? 300 degrees Celsius. That's the answer for the first question. All right. So you can expect a question to convert from Kelvin to degree Celsius, or sometimes it can be asked the reverse, like degree Celsius into Kelvin. Okay. So please understand that conversion as well. Second one, what is the physical state of water to 250 degrees Celsius? We know that at 100 degrees Celsius, water starts boiling. So at 250 degrees Celsius, we can definitely say it will be in gaseous state or the vapor state. Then at 100 degrees Celsius, boiling just about to start, right? So we can say that liquid can also be expected, and certain particles will, they have already been started to vaporize. So we can have gas as well. Both the state will be there. Now the third one, for any substance, why does the temperature remain constant through during the change of state, right? So during the change of state, the temperature that we supply, or the heat energy, is being utilized to overcome the force of attraction between the particles to get changed from one state into another, and it is stored in the form of latent heat. All right. So that's answer for this question. And the last one, suggest a method to liquefy atmospheric gases. So temperature has to be lowered, pressure has to be increased. Then we can change from one state into another. All right. So that's all regarding the third session of the chapter, Matter in Our Surroundings. I hope whatever we have learned so far is very clear to you. We have learned nothing but the interconversion of states of matter from one state into another. Okay, different pros are there, different definitions are there. The main definitions you have to learn about: evaporation, boiling, melting point, boiling point, latent heat of vaporization, and latent heat of fusion. All right. So let's see in the next session. So thank you for watching. Okay, bye. Thank you.